All right, welcome back everyone to another explainer. Today we are building your essential field toolkit. Look, whether you're gearing up for the ACI Shotcrete Inspector exam or you're out there in the dirt doing QC right now, you know that keeping track of all these numerical limits can feel incredibly overwhelming. Well, today we're fixing that. We're going to gather every vital number and acceptance criteria and put them into one master visual guide. Let's get started.
So here's our roadmap for the mental toolkit we're building today. We'll kick things off with test panels and physical dimensions, move into weather and curing limits, lock down your nozzle distance and pressure requirements, and then tackle those absolute make-or-break Shotcrete acceptance criteria. We'll wrap the whole thing up with a fast-paced exam review and some real-world field scenarios to test your judgment. Okay, let's dive right into Section 1, Test Panels and Dimensions. This is where your daily verification actually begins.
So how often do you actually need to shoot a test panel under ACI 506.2? Well, you have a very specific checklist. You're going to need a panel for each mix design, each nozzle man, and each workday. There's also a volume trigger to watch out for, which is one panel for every 50 cubic yards placed. But from the inspector view, here is the golden rule you absolutely need to remember. You always go with whichever condition gives you the most panels. You never default to the easiest metric, right? You always default to the one that demands the highest frequency of testing.
Now, once you know how many panels you need, you've got to verify their size. The absolute minimum dimensions here are 16 inches by 16 inches with a minimum depth of 5 inches. And unless the project specs explicitly tell you otherwise, these panels need to be shot vertically. Later on, when it's time to extract cores from those panels for testing, the nominal core diameter you're looking for is exactly 3 inches.
Moving right along to Section 2, Weather, Temperature, and Curing. Environmental constraints can literally make or break a placement, so this is a heavily tested category. Let's talk about curing. Under normal conditions, the rule is 7 consecutive days or until 70% of the specified compressive or flexural strength is reached, whichever of those happens first. But check out the cold weather rules here. If you're in cold weather, that rule changes entirely. Protection has to continue until the specified strength condition is definitively reached. Also, keep in mind that natural curing can only replace your specified curing methods if the relative humidity in contact with the shotcrete stays at or above 85%. And, this is key, the engineer actually authorizes it.
Okay, this next part is a massive exam alert because these numbers get mixed up all the time. For hot weather, your shotcrete material temperature limit is 95 degrees Fahrenheit. But your reinforcement and receiving surface limit is slightly lower, coming in at 90 degrees Fahrenheit. The absolute most important thing here is not to confuse these material and surface limits with the ambient air temperature. They are completely different measurements, so don't let them trick you. When we're talking about cold weather, the line between good practice and bad practice is black and white. If it's 40 degrees Fahrenheit and rising, you're good to proceed. But your shotcrete material temp, when shot, has to be at least 50 degrees Fahrenheit. Now, if it hits 40 degrees and is falling, you must stop unless proper protection is provided. And the ultimate zero-tolerance bad practice, never, under any circumstances, place shotcrete against a frozen receiving surface. Just don't do it. Now, when it's finally time to remove that cold weather protection, you can't just rip it off and shock the system. During the 24-hour removal period, a section that's less than 12 inches thick can only drop a maximum of 50 degrees Fahrenheit. If it's a thicker section, say between 12 and 36 inches, that maximum allowed decrease actually tightens down to just 40 degrees. All right, let's hit Section 3, Nozzle Distance and Pressure. This is all about what the nozzle man is doing in real time. The critical factor here is effective water control in dry mix shotcrete. To get this right, water pressure at the nozzle absolutely must be at least 15 psi higher than the air pressure, period. As an inspector, if you aren't verifying that pressure differential, you simply do not have control of the mix. Switching over to wet mix shotcrete, you're usually looking for a nozzle slump range of 2 to 4 inches. And as for the physical setup, the standard nozzle distance typically ranges from 2 to 6 feet away from the receiving surface. Of course, that's going to depend a bit on air volume and your specific site conditions, but 2 to 6 feet is your standard window. Okay, pay close attention, because we are now entering the most critical phase of our explainer. Section 4, Shotcrete Acceptance Criteria. These numbers quite literally define whether work is accepted or rejected. Here's how this builds into the ultimate judgment call. For compressive strength, acceptance requires 2 very specific conditions to be met at the exact same time. First, the average of 3 cores has to exceed 85% of the specified strength. Second, No individual core can fall below 75%. You have to verify both. One without the other is a flat-out failure.
But compressive strength isn't the whole story. When bond strength is required, the average of the cores must exceed the specified minimum. And again, no single core can dip below 75% of that specified strength. For flexural strength, the average of 3 test beams from one panel has to equal or exceed the specified requirement. And finally, for boiled absorption, the average has to satisfy the specified limits, with no single result exceeding the limit by more than exactly 1 percentage point.
All right, Section 5, Fast Exam Review. We've thrown a lot of numbers your way. Let's do a rapid-fire mental flashcard session to really lock these in.
Ready? If you see the numbers 85 and 75 paired together, what should instantly pop into your head? Boom, compressive strength acceptance. Let's keep it going. If you see 15 psi, think dry mix water pressure over air. If you see 16 by 16 by 5, think ACI test panel dimensions. If you see 50 cubic yards, that's your panel frequency trigger. And if you see 95 and 90, think hot weather limits for shotcrete and surfaces. Seriously, cement these pairings in your mind. They are the absolute foundation of your inspection toolkit.
Finally, Section 6, Field Scenarios and Takeaways. Because memorizing numbers is great, but applying them in the dirt where real decisions are made, that's what really matters. Let's test your judgment with 2 quick scenarios.
Here's your first dilemma. You're on site, and 3 cores just came back from the lab. 2 of the results are incredibly high, pulling the overall average way above that 85% mark. But that third core, it comes in below 75% of the specified compressive strength. As the inspector, what's your call here?
Your required action is to flag that the requirement is not satisfied. Look, even though the average looks fantastic, you cannot approve the work because that single core criterion failed. Both rules matter, and a failure on one individual core means the acceptance criteria have not been met. Okay, let's flip the script for scenario 2. This time, every single individual core tests above 75%, so your single core rule is completely satisfied. However, the average comes out to only 84% of the specified strength. What do you do? Once again, the action is exactly the same. The requirement is not satisfied. Sure, the individual cores passed the minimum threshold, but that average fell short of the strict greater than 85% rule. You can't approve this work because both parts of the criteria must be fulfilled simultaneously. No exceptions. As we wrap up this explainer, I want you to walk away with 3 key things. First, know exactly which number belongs to which condition. Don't go confusing ambient air with surface temperatures. Second, acceptance criteria almost always require both average performance and individual limits. You literally can't have one without the other. And lastly, verify before you apply a memorized number on site. Numbers are completely useless unless they're connected to the correct field decision. So I'll leave you with this provocative thought before our next explainer on ASTM testing protocols. If you memorize every single number in the book, but you fail to verify the context on the job site, have you really inspected anything at all? Think about it. See you next time.